Your angle is the same way as you always go, right? So I just go angle first. All right, so let's do this. What?
How do we simplify it down? So how do we find our 5 pi over 4?
Well, that would be 10 pi over 8.
Yeah.
That doesn't help you much, huh? Let's see here. That would be 15 pi over 12. So you can do it that way by doing 12.
So then just subtract.
Compare it to the other ones, right? You've got 14 pi over 12 on the bottom.
What? I don't see a 14 pi over 12.
What's 7 pi over 6?
14 pi over 12.
So you can do it that way. That'd be a way to do it. All right. So that's number 1 is right there. Number 2. Number 2. Which is 3 negative 135 degrees. So 135 degrees would be here. 3 would put me right about here. Doing number 2.
Should we not do 7, 8, 9?
You should look at them. I don't know if you could. You're probably not going to be able to do them.
I said here because of this negative.
But instead of walking this way, I'm going to walk this way instead.
Easy money.
And that's number 3.
For each polar equation.
Yes.
What you talking about? Article 3.
Four isn't. No, that's 5.
Is that 5?
Yeah, that's 4.
5.
Yeah, that's 4. No, it's 4 is negative 2 over pi over 4.
Right. Right. I'm doing 5 accidentally. I'm doing 5.
That's 5? Oh,
It's
is that
5.
4?
I skipped. I hope. When did I do wrong? 1 5 pi over 4. 1 5 pi over. Yeah, no, that's number 5. Actually, I skipped 4. My bad.
So you skip 4.
I skipped 4.
Your thing might be off a little bit.
5. So I've got 5 pi over 4, which is more than pi, 0 and pi. So it's a quarter pi past there, right? So the quarter of the way around past on this side. And it's out 1. So I go out 1, put a dot.
So it's on the line of 7 pi over 6.
So what?
Is it on the line?
No, I'd be halfway between the two, right? Because 7 pi over 6.
7 pi over 6?
Yeah, I'd be halfway between the two.
Because when it's 14 pi over 12,
Right. That was 14 pi over 12. The other one's 16 pi over 12. So 15 pi over 12 would be halfway between.
Yeah. Sweet. So isn't a little smidge in between the 0, the negative? Yeah. Without having a line, it's kind of difficult, but whatever.
Do 6. 6. Let me get a pretty color. Let's go pink. Okay, so 6. 6 is 2, comma, negative 2 pi over 3. So that'd be 2/3 of a pi around this way, correct? To be right about here, it's on the line that says 4 pi over 3.
Yep.
Okay, and it'd be out 2, so it goes right here.
Okay. I think he's gonna work on the radius, like thing. You get
That's what? Oh, radians, yeah.
Wait, so where, how did you?
That's a U problem.
Well, like we can just convert it to degrees and
You
figure it out
could.
from
You
there.
could absolutely convert it to degrees, and what am I going to say?
Why don't you just give it to us in degrees?
Good job.
Because you have to know radians. You're in a trigonometry
Oh, no,
class.
actually.
Wait, are we?
At some point, you're supposed to. I'll tell you the truth. This is trig pre-calculus. In calculus, if you use degrees, you're going to get the problem wrong. 100% guarantee. We completely convert to radians. Now, that sounds horrifying to you, but frankly, they don't use it to the depth you guys have already learned it, so it's not really a big deal. It's just conversions. What? We could do number, well, okay, let's do number 4. 4. 4. 4 is in red. 4 was -2 pi over 4. So I go pi over 4 would be right here, right? I'm going to go -2 instead, so I'm going to put a dot right there. Good? All right, so let's look at how would we graph an equation? How do we graph an equation when I have a line? Normal Cartesian. Let's say I'm going to graph y equals x plus 2. What do I do? Make a table. X and y. And I'm going to plug in values of x. Start with -2. That gives me 0. -1 gives me 1. 0 gives me 2. 1 gives me 3. 2 gives me 4. Correct? And then I just draw my dots. I go boop, 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 and I draw my line, and I'm done.
That's a really good line.
Now, guess what?
That's a really good line.
What are we going to do with graphing these?
Same thing.
Same game. We're going to start off with our circles. We have our circles. Boom. 1, 2, 3, 4. That's terrible. Oh, well, life's full of challenges. The equation they give us. The equation they give us is r equals 3. Now, again, this is a nasty example to start with, so I apologize, but we're going to start with this nasty example because that's the one they gave us. And remember I said it's usually easier to start with theta and then do r? I'm going to write theta and then r. I'm going to be consistent in that because that is actually a much easier way to go about your life. Go the other way around, you're in for trouble and sadness. Okay, so when I pick an angle, now do you guys want to use radians or degrees? Let's use radians because they have radians on the sheet.
Darn it.
Overruled. 0. When I put a 0 radians in this equation, everywhere I see a theta. Some of you are confused. Think about it. Everywhere I see a theta, I'm going to put a 0 in there. What do I get? 3. Good call. I'm going to put a pi over 6 in there. Everywhere I see a theta, what do I get? 3. Well done.
Wait, what's the math behind this? Just because?
Where's the number? Where's the theta? You need thetas?
It's always going to be 3.
Oh, it's going to be 3. Just like when we had y equals 2. And we put in our values of x, and guess what we got? 1, 2, 1, 2, 2, 3, 2, 4, 2. Right? We're the same thing here. We got pi. Well, we've got pi over 3 is the next one they want us to do. What do I get? 3. This is getting boring. How about pi over 2? 3. Any chance it's going to change anytime soon? No. So now I'm going to graph it. Graph each of the points. You're going to not have an arc. You have something even more magical. A super arc. 1, 2, 3. You put a dot right here.
A pi.
You put a dot right here. You put a dot right here. Put a dot right here.
Oh,
You have a circle?
Put a dot right here. Oh!
Wow.
Oh! Oh!
how is this a mark?
And in algebra 2, did you guys do polar coordinates? He said with some trepidation.
No.
You were our teacher.
I was your teacher second semester. You're supposed to learn it first semester.
I didn't learn anything.
I asked her Bells. Bell was just kind of like,
All right, we'll do polar this year too. Good luck with that. You're gonna love it. So I was about to point out this is a much easier format than the other side, but since you've never seen the other side, you can't possibly believe me. So that's okay. So that's a circle. So r equals a number, graphs a circle, which makes some sense because r equals 3 means graph all the points that are 3 away from the center. That's a circle. Yeah?
yeah.
Let me try the next one, see if you get it. So, table x, y.
You don't do
Why is
that.
Oh, what am I doing? Theta, r.
Beta row pi. What is the R stand for?
R is the radius, how far out you are from the center, right? So now, here's where things get tricky. I start to put in 30 degrees, and I realize I got a problem, right? Can I have 30 degrees?
Oh.
That's weird. I can put in 60 degrees. What's my R value? Could be anything, right? Let's put a 1 out there. How about 60 degrees? 0. 60 degrees. 2. How about 60 degrees?
3.
-3. How about 60 degrees? +3. Oh, 60 degrees, 5. Good. We'll put 5 in there. Make everybody happy. All right. So how do I graph this?
Just a line.
It's just a line. You go here. You got a point. Here 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 you got a point. Oh, that's terrible. That's a little too close. And there's my line.
You have to draw the arrow.
You should.
Draw the line. And if it's a circle, you draw a circle.
Yeah.
Okay.
Okay, everybody should be able to do 9 super, super easy. And then we'll talk about how you're supposed to know how to do 10 and 11 already, but probably